Just write down shit.
We have done this before. Thank you for remembering, James. But we need to do it again for this chapter. So does anybody know what these special numbers are called? What are they called? Not square roots.
Still use
Yes, Alice.
numbers.
Perfect squares. They're perfect squares. Because what's the square root of 4?
12.
2. What's the square root of 9?
3.
Square root of 16? 4. No decimals, right, when I take their square roots? That's why they're perfect squares. Okay? All of these. What if you took the square root of 8? Would that be a decimal?
4.
No.
What?
It's a decimal, so it's not a perfect square. Square root of 10 would be a decimal, so it's not a perfect square. Those that have square roots that are whole numbers. You're going to need that list. Keep it handy. Okay? So, this definition for radical is kind of long, so write small. Are you ready?
Whoa, that's it?
That's it.
Are you
Oh, I
serious?
actually wrote small.
Gotcha.
Wait,
All right. Now, that's a radical right there. We always call it the square root sign. It's called a radical. It's another word for it.
Square root sign it is.
Okay. So, radicand is, you ready? Just a little bit longer. Under
Oh,
the,
good one.
there you go.
That's so much.
That's the radicand.
Oh, slow down.
So that means if there was something underneath here like 4x, 4x would be the radicand. Make sense?
Right, can't.
Are we going to use that word very much? Probably not, but in case you see it in the book or something, you'll know. All right. What do you notice about all these numbers, all these radicands? What do you notice about them?
Perfect.
They're all perfect squares, so you can just do those in your head. What's the square root of 49? What's the square root of 100?
10,
16.
12.
Square root of 64. Vinny is hung up on the number 12 today.
My favorite number. I've actually
Okay.
said that like 50 times.
Okay. Now, you may not have seen something like this before, but
I already
does
know.
anybody know what the answer is?
2.
It is 2.
Wow.
It is 2. Because what undoes addition?
Subtraction.
What undoes multiplication? What do you think undoes square root? Squaring. Opposite. The opposite of square root is squaring. So actually, square root and squaring cancel each other out, and you're just left with the radicand, or 2.
Please tell me this is 12.
Okay? This one here, square root of 2 squared is 2, plus square root of 5 squared, what would be here? 5. So 2 plus 5 is 7. And that's just warm-up. That's just review. Okay? All right. So you're going to be doing 2 things here with square roots. You're going to be using your calculator, and you're not going to be using your calculator and simplifying. So there's 2 different things. You've got to read the directions to know. It says find the square root, round your answer to the nearest tenth. This means I can use my calculator. So find the square root of 74. What is it? It's 8.6. The nearest tenth. This is the 10th place right here. Okay. All right. Approximately 8.6. Now, wait a minute. That was the first part. Now I got to do this part. Check that your answer is reasonable. So, I have a question. 74 is between what 2 numbers on this list? Okay, so if I take the square root of 64, what does that equal? What does the square root of 81 equal? 9. And this falls right in between there, so that's reasonable, isn't it? So yes, it is a reasonable answer. It should be between 8 and 9.
I got it. I know it's 12 now.
Make sense?
Yep.
Okay, what's the square root of 8 to the nearest 10th place?
3.6.
2.8. Is that what you were going to say, Allison? Okay, checking to see if it's reasonable. What 2 numbers does 8 fall between on this list? 4 and 9. So if I take the square root of 4, that's equal to 2. If I take the square root of 9, that's equal to 3. The square root of 8 falls right in between there, doesn't it?
Oh,
So 2.8 makes sense. So that's what you have to do for that. Okay? All right. Oh, look at that. Use the Pythagorean theorem to find the length of the hypotenuse to the nearest tenth with the given side lengths. Oh, I got to use the Pythagorean theorem? I'm going to write it down right now
wow.
for both of them. All right. They gave me these side lengths, not the hypotenuse. They gave me the side lengths. So I got to use those. That's going to be my A, square root of 5 squared. Square root of 6 squared equals C squared. Square root of 5 squared is just equal to what? 5.
6.
So 11 equals C squared. Do I want C squared? I want the square root of C. I want C by itself. Now, it says to the nearest tenth, so I can go on my calculator, and it's equal to approximately 3.3 if you did square root of 11 on your calculator. Okay, here, they gave me 6, straight up. 6 squared plus the square root of 13 squared equals C squared. So what's 6 squared?
6. 12.
36 plus 13 equals C squared would be 49. Aww, it's a perfect square.
Oh, how weird is that?
So if I take the square root of both sides,
7.
C is going to be 7.
Yes. Thanks.
Beautiful, huh? Okay.
Tell me one equals 12.
Okay, look at this word right here. Simplify. Simplify means you do not use your calculator. Can't have any decimals. What you're going to do is you're going to find the biggest factor on your perfect square list. Factor is what the number can be divided by. Find the biggest factor on your perfect square list. Okay, so to start out, we have the square root of 28. You do not go to your calculator. Well, I mean, you might have to figure out, but does anybody know what is the biggest thing that 28 can be divided by that is on this list?
9. 7. 5.
It's 4. Now, if you don't know, this is what you do. You go to your calculator. Okay, I'm going to start trying some of these numbers. Let's try, I try 16. So 28 divided by 16. That gives me a decimal. I can't work with that. So go down a little lower. 28 divided by 9. That doesn't work either. So if I do 28 divided by 4, that gives me 7. That's what I need. Okay, so I'm going to go to the back side here, and I'm going to write this as this, square root of 4 times the square root of 7. Because 4 times 7 is 28. Perfectly legitimate. How does that help me?
Oh.
Because I can take the square root of 4. I can get 4, break 4 out of prison, if you want to look at it like that. Take the square root of 4, it's 2. And then I still have the square root of 7, and I cannot go any further because this is going to be a decimal if I do it. And so, no decimals in your answer. No decimals in your answer. So this is as far as you can go. All right? Now let's do another one. 54. What's the biggest number that 54 can be divided by that's on that list? Does anybody know?
54.
Divided evenly. No decimals.
6.5. What is it?
I know, some of you are not great with your
9.
times tables. Figure it out on your calculator if you don't know. Start with a bigger number, try it until you find the biggest one, which is 9. 9 times what gives me 54? 9 times 6. So I'm going to write it split up like that. What's the square root of 9? Now I can break the 9 out. And I just have this. I can't do anything else with 6, so that's my answer. What do you think the biggest common mistake is? Just like people forgetting to divide by 3 in the last chapter, here's what people do. Don't write this down, just watch. So they're at this point. And then they do this. What's the problem? Something here is a problem. What's the problem? What? Yeah, they took the square root of 9 and wrote 3 down, but then they left that radical. No. You're breaking that 9 out. That radical goes away. So don't do that. Okay? All right. So let's try another one. Biggest thing that 25 can be divided by on that list, or 125, I should say. 25.
25.
How many 25s go in 125?
5.
5. Break that 25 out. What's the square root of 25? 5 times 5. What's the biggest thing that 200 can be divided by on that list?
100.
Jana, put it in your backpack. Break that 100 out. What's the square root of 100? There you go. Okay? So you're going to be doing that as well. Multiply. Oh, wait. So if we went from here to here, could I not go from this to that?
Of course you can.
Huh? So look, we have the square root of 5 times the square root of 6. I can put them together under 1,
Yes.
which is equal to what? Square root of 30. Multiplied the radicals.
Is it?
Mm-hmm.
Okay, next.
Then we have the square root of 3 times 12. I put them together. And 3 times 12 is 36. I can take it one step further because it's a perfect square.
Wow.
What's the square root of 36?
6. Oh, don't put in square roots.
Okay, this one's slightly different because the 2 is outside. The 2 just comes along for the ride. It stays there. It doesn't go anywhere. And then I put these two together. And it's 2 times the square root of 35. And that's all I can do with that. But I got to show you one more bonus problem. Okay? So make a little box here.
Wow. Is this in addition to all these?
In addition.
Wow.
So let's say you have something like this, in parentheses, and all of it is squared. You want the easy way or the longer way?
Easy. Medium.
Okay. The parentheses are saying that the whole thing is squared. So here's what you do. You take the square and you put it on each thing individually, separately. And you write it like this. 4 squared times the square root of 3 squared. Okay. What's 4 squared? 4 times 4?
16.
What's the square root of 3 squared? 3.
9.
So 16 times 3 is 48. Look how easy that was.
All right, let's get to the next one.
Okay, now we're going to practice this. Somebody said it. 90 degrees. It's got 90 degrees in it. It's a right triangle with angle measures of 45, 45, 90. Pretty basic definition. It's a right triangle with angle measures of 45, 45, 90. Now, You've been practicing Pythagorean theorem already, so we're not going to do that right now. But we are going to refresh our memory about number 3 and 4 here. Back when we worked with triangles and base angle theorem and angle sum theorem and all that fun stuff, we need to think about again. So, what do these little things mean down here? Those things right there, what is that telling you?
That they're congruent.
That they're congruent. Okay, if those are congruent, then what do I know about these sides? Yeah, because of the base angle theorem, it tells us that the opposite sides are also congruent. So I'm going to put a line here. Tells me they're congruent. And that helps me, and none of you should have any earbuds in your ears right now. Take them out. Thank you. So you have 24 equals 2x plus 8. And then when you solve it, you get x equals 8. We're not going to spend a lot of time on that because this is still review. Okay, on the flip side of that, they're telling me that these sides are congruent. So that means that these opposite angles are also congruent. And they're saying that this one's 47 and that's 5x minus 18. So I can set them equal to each other to solve. And that would give me x equals 13. So let's just review. Here's what we're going to be working with today. 45, 45, 90 triangle. The length of the hypotenuse is the length of a leg times the square root of 2. That's a lot of words to say this. Leg times the square root of 2 equals hypotenuse. That is what you're going to be working with today. Now if you think about it, you have a right triangle. This is 45. This is 45. What does that tell me about their legs? What does this picture tell me about the legs? If these two angles are equal, what about their opposite sides? They're equal, aren't they? So it doesn't matter what leg you use in this equation. It doesn't make a difference. If it's 45, 45, 90, the legs are equal. Okay? All right, let's work with this a little bit. Turn it over. All right, remember, if it's 45, 45, 90, that means I can use this formula. They tell you it's 45, 45, 90, you're going to work with that more than likely. So write it down here, 45, 45, 90. I'm going to plug in what I can tell from the picture. How long is the leg? The lake. How long is the hypotenuse? Oh, look at that. If it doesn't say otherwise, I can leave my answer in that form. I'm done. The hypotenuse is 17 times the square root of 2. Okay, this is also 45, 45, 90. So that means that the leg times the square root of the 2 equals hypotenuse. Plug in what you know. How long is the leg? How long is the hypotenuse? 13 times the square root of 2. I got to solve for x. What do? Except this is times. So what would I do? Divide. Watch what happens. It's pretty neat. Divide by the square root of 2. Cancel, cancel. X equals 13. Would you look at that? X equals 13. Easy enough, yes? All right. So one thing you're going to do today is work with this equation. The second thing you have to do is a little bit of reasoning, stating why something is that it is. So determine whether there's enough information to conclude that the triangle is a 45, 45, 90 triangle. In order to do that, we have to explain how we know that each angle is what it is. So let's look at the picture. This side and this side is congruent. This is 45, therefore this is what? because, does anybody know the name of that theorem? What are these angles called? The base angles, yes. So the base angle theorem tells me that angle B is congruent to angle C. If you just cannot remember the theorem name, just say angles opposite congruent sides are equal. Good enough. Okay? So that's the first thing. Now I got to prove that this is 90. How do I know that's 90? Ah, thank you. The angles add up to 180, don't they? So, because of the triangle sum theorem, angles add to 180. Therefore, the measure of angle A is equal to 90 degrees. So I should write here the measure of angle C is 45 degrees. Okay, so I've written down a reason for the 45 and the 90, and I can say that means it is a 45, 45, 90. Reasoning, just a little bit of reasoning. You're not writing a proof, just writing down some reasons. Okay, let's do one more with this reasoning. Show that the triangle is a 45, 45, 90 triangle, then find the value of x. All right, so let's look at this. We know that this angle is what? 90. We know these sides are equal. Therefore, their opposite angles are what? Equal. And they have to add up to what? All three, 180. So if I say 180 minus 90, because I know this one's 90, that leaves me 90 left over to cut in half exactly. So each angle is 45 degrees. Oh, that is the triangle sum theorem, but we'll just say that. So we know that this is 45 and this is 45. The triangle is isosceles. There is a blast from the past. So the base angles are congruent. All right. Proven that it's a 45, 45, 90. What's the next thing I have to do? If I know it's a 45, 45, 90, what can I use? This, right? That's what I'm going to do. Leg times the square root of 2 equals hypotenuse. Plug in what I know. The leg is x. The hypotenuse is 20. And then how do you finish it? Divide by the square root of 2. X is approximately 14.1. Okie dokie?
No.
You still have